Thank you for coming. My name is Brian Geffon. Joining me is Dmitry Markovich. We're both software engineers at LinkedIn. We work on a team at LinkedIn called Traffic Infrastructure. What that is mostly we specialize in all of the infrastructure related to incoming traffic, routing, and all the optimizations that take place. So most of our proxy tiers, our server infrastructure, that's all owned by us. So the talk today is titled Server-Side Execution of JavaScript and what could possibly go wrong. So server-side execution of JavaScript is not something new. This is something that has been going on for a while now. Node.js has really popularized this. This talk is not about Node.js. This talk is about how we got into a mess where we had to execute JavaScript on the server side and the problems that happened with them. So I'll start off by giving you guys a brief history of how we got into this situation, why we got into this situation, and then we'll talk about how our architecture shifted over the years to get to this new weird state where we're executing JavaScript on the server. And finally, Dmitry will take over with the more interesting part, which is what goes wrong. And things do go wrong when you start executing JavaScript on the server side. So let's get started. So LinkedIn 2003. This should look very familiar to most people. This is your classic web architecture. It's your simple web architecture, I should say. Monolithic, one application framework, one templating framework, output on the server side. You run some Java code, run through a JSP, out comes HTML, client gets HTML. It's the classic, simple, monolithic web application. The problem with this is this doesn't last for very long. Most companies, as they grow, they start moving away from this monolithic design, and they start getting into way more complex architectures very quickly. So this nice paradise rarely stays for very long. So at LinkedIn, it actually stayed for quite a while. So starting in 2009, 2010, we started bringing in new frameworks. So where we used to be Java and JSPs, now web app teams started coming to us saying, we want to use Grails, we want to use Rails, we want to use Python Django, we want to use, so on and so forth. It's really never ending. So teams will come to you and say, we're going to be most productive with language X. And then as an infrastructure team or an infrastructure org, you need to be able to support that somehow. Sometimes you have to put your foot down, but sometimes you need to be able to support these new technologies, because it does give a productivity boost to your app teams. And the problem is you're going to have product guys breathing down your neck, we need to get this out, we need to get this out, and this framework is about to make it happen for our engineers. So you end up having to support all these different frameworks. So the problem is, with this productivity boost, there's going to become all kinds of additional complexities. So the first one being, you need to be able to maintain a consistent UI across pages. Regardless of the technology you choose, you have to be able to have a consistent UI. Otherwise, it just doesn't work from a product perspective. You cannot have an inconsistent experience. Additionally, you want to be able to reuse as much as possible. So how can you do this in such a way where you can say that this team over here can go Ruby and ERBs, this team over here can go Grails, and this team over here can continue with JSPs? We want to share as much as possible across each of those different frameworks. So this is definitely added complexity that comes with supporting this. So how are you going to resolve this? And really, the solution comes down to you need to use a single templating language. You need to unify your templating language so that you can share across all these different frameworks. Otherwise, you're going to end up duplicating your logic everywhere and rolling out new changes to, let's say, your header or your footer become an increasingly complex problem. So the question is, what do these languages share? So what is the foundation for all these frameworks? What is the foundation for everything? So one thought would be, well, what if we went really low level? What if we went C, let's say? Everything shares C. Everything can be Java can do C through JNI, you can do it through Ruby, you can do it through Python. You can do it anywhere. So could C be the foundation or the shared layer that everything can use so you're not duplicating logic everywhere? That doesn't seem like a good idea. That does not seem like a good idea. So there's two key requirements when you're considering unifying your templating language and unifying as much as possible. The first one, you don't want to repeat yourself, because we've been doing that. We had three different frameworks, 3 different templating languages. You start repeating yourself, it doesn't work. You can't repeat yourself. And you want something that needs to be supported across all the architectures. Like we said, C is an option, but let's face it, it's not really an option. So after racking our brains, we decided that the solution should really be client-side templating. So one thing that's the same across all these technology stacks is their output. Their output is HTML, and with that HTML comes JavaScript. So what if we push the templating down to the client? Now what we could potentially do is share these templates across all of our different frameworks and have a unified, consistent experience without having to worry about the headaches of duplicating logic. So the idea was simple. Web applications return JSON data. That JSON data is then consumed by JavaScript templates. Any framework can output JSON data, and 99% of browsers can execute JavaScript. So it seems like a win. It seems like a win, and it seems like it could work. So what does that look like? JSON data comes from the server, JavaScript templates on the client. Like I said, JSON, JavaScript, HTML, completed output. So now that we have this system that allows us to share templating across our frameworks, that also means that we can share UI. What that means is that one application team that has decided they're going to be most productive working with, let's say, Play Scala. Another application team has decided they want to use Java with JSPs, and let's say a third team has decided they want to use some other framework. By unifying into JavaScript templates, they can now share their pieces across each other. So you can embed a component from another team in your page because you're all speaking a common language, because you're all using JSON to represent your data models, and you're using JavaScript as your views. If you want to take an MVC approach to it, you use your JSON and your JavaScript as a view language, or as a view layer, I should say. And so now everything can be shared across the board. So that's a really neat little side effect of doing this in the first place. Additionally, by moving to JavaScript, there's an interesting property in that you don't need to ship down your markup anymore. You ship down your markup once, and now you're worried about shipping down your data. Your markup remains cached on the client. And this is a nice little property of doing client-side template. Great, so JavaScript templates. There's a lot of them out there. I'm sure these are names a lot of people have seen. Handlebars, Mustache, Dust.js. There's no shortage of JavaScript templating solutions. So we evaluated something like 25 when we were considering doing this a few years ago. It was 3.5, 4 years ago when we decided this. And so we looked at 25 different templating solutions. And each one had its trade-offs. Each one had its upsides, its downsides. But for us, the winner was Dust.js. So Dust.js was a project we found, basically abandoned. And we decided it had everything we needed to do what we want to do. So the things that were critical for us, it needs to be logicless. We need a templating language that's logicless. We needed something that's very extensible, and we needed a language that's inherently dry. So we don't want to repeat ourselves. We were already doing that before. That was something we weren't willing to budge on. We cannot repeat our logic anymore. It just wasn't scaling. So this is a project we tried to take over, and it's available on GitHub now. We're actively contributing to it. So if you're interested in using Dust.js, it's available on our LinkedIn GitHub page. So let's take a quick look at an example of what we've done here. So now what we do is we have our engineers writing templates in Dust.js. So that top line there is an example template that would be written in Dust.js. It's going to get compiled to this JavaScript. Like we said, this JavaScript is then going to will then consume JSON data. So here's an example of just a simple substitution. and the output will be HTML. Actually, this example here, I just realized has gotten changed. But actually, it should say name is a, and then occupation. So that's an example of how the substitutions happen with the client-side templates. So now we've started this paradigm shift. We've started moving away from server-side templating, and now we're moving to client-side templating. So how can we take advantage of all the other side effects we talked about that come with client-side templating? Like we said, reusable UI and things like that. So the reusable UI gives rise to component sharing. So although previously our applications weren't designed to have components shared, well, why don't we re-architect a few things in this process so that we can start sharing UI? Now, we've also started separating our components from the data models, which is, as anybody knows, a great way to go. And because we can do component sharing, perhaps what we can do is we can avoid round trip times by embedding components from other pages before it leaves the data center. So a common pattern is you ship your page down to the client, you have some component on the page, which is then after the page is loaded, it goes back to your exact same servers again and fetches that some component dynamically. Well, what if you could do that on the server side? It turns out that this is, there's a lot of pages where this actually makes sense. So let's take, example. You have a profile page here. It's broken up into these really, clean, distinct pieces. So by using reusable UI, these can be owned by different web applications on different stacks, and they can just be embedded in. And by speaking a common language, we can just embed them in on the fly. So, and this is common, this abstraction is very common. If you look around at those sites, you'll see that things can really be divided up into nice, reusable components. So we created this server called Fizzy. It's a UI content aggregator. And the way it works is it allows you to stitch in components from different places into a completed page. So we just looked at the profile page. And on the profile page, you might have some contact details, you might have your profile details, and you might have a couple other components. So we'll take a quick look at a simple example of how this is all stitched together and how hopefully it'll start becoming clear where JavaScript execution comes into play. So the name Fizzy really doesn't have any significance, it's just the name we picked. So let's take a look at this. We looked at the profile page. So this profile page, what does it return to this UI component aggregator? Well, it all starts, you return some headers. These headers are the key to the UI aggregator that it needs to go off and fetch additional components that need to be stitched into the page. And those instructions we've done through JavaScript tags. And the reason we chose JavaScript tags is not because this is designed to be executed on the client. This is actually designed to be interpreted by the server. However, by doing script tags, there's a nice little property in that if we decide we want it to be aggregated on the client, it's actually possible. So these FS embedded script tags could be translated into AJAX calls, let's say. And so again, now you can start doing aggregation on the client side if you want. So this is what the server sees. So this is an instruction to the server that now it's time to go off and fetch some profile summary component and stitch it into the page. So now it's going to go off and it's going to fetch some submodules, and those submodules are then going to return their own content. Now, because remember we're going with client-side templating, each of those client templates need to tell the UI aggregator what type of JavaScript it needs and what the entry point to that template is, because on the client needs a way to know how to bootstrap this process. So each of these submodules are now going to return some JavaScript, which is this is the actual template, the JavaScript template, and the entry. The template keys represents the entry point into that template. And again, the body type of this is application JSON. Remember, our templates are JavaScript, which can consume JSON data. So here's an example of a completed response from one of those individual components. So going back to our original example that just contained one embed, which represented a profile summary, this is what the browser sees. So all of that's going to get replaced in with some bootstrap code, a script tag pointing to the JavaScript template that's going to be executed on the client. The JSON data is stitched into the page as an HTML comment. And then finally, you have the bootstrap code, which goes off and actually executes the template. So it consumes the JSON, and out will be some HTML that will represent some profile. So we have this fancy new architecture. The components are standalone. We have UI separation. So we've really come a long way here. All our UI is completely separate, and everything is reusable. So there's certain things that still can't be solved with this approach. And so we had to invest in client-side internationalization and localization. Now, this is actually a pretty tough problem to solve on the client side. And it's one that took us quite a while, but we're finally getting there. But all in all, for developers, it's really a big win. But rarely is that the end of the story. Rarely is it, okay, we introduced this new architecture. This architecture worked great. Our developers were productive. End of story. That's really not ever the case. So Dmitry Markovich, he has a lot of experience of dealing with how this works and what can end up happening when you start doing client-side templating. So I'll let him share some of that information now.
So yeah, we introduced this client-side rendering engine, and as Brian mentioned, it used to work for our engineers, but it doesn't used to work from, let's say, infrastructure point of view and site performance point of view. And how do we behave with all of these new things in client-side rendering on different types of browsers? So the biggest problem is as an infrastructure team, we can't make business decisions to quit, let's say, IE7 users. We still have a lot of IE7 users, even IE6. And our company is still thinking that those types of users are bringing a value to our business. So that's why we can't just say, like Facebook, we quit them and we will continue this as client-side rendering. So with IE7 at least is that IE7 doesn't have a native JSON parser, and this is a blocking point for this solution at all. So moving forward is what else can go wrong? When we're executing a lot of JavaScript on a client, we're kind of leaving the JavaScript uncontrolled, and we give it to our users. So we are not controlling, let's say, how long it takes to run the JavaScript on the client. And it could take a while. So most of the browsers, not most of them, but let's say 2-3 years old browsers doesn't have optimized JS engines. And I would say even modern browsers sometimes don't run JavaScript as fast as we can do that, let's say internally. So one other thing is with client-side thing is one of the valuable points of our traffic are the SEO, like search engine optimizations, Google, Bing, Yahoo bots, and all different bots that indexed our pages. And not all of them are doing that good with JavaScript. So, and one of the reasons, like let's say these days and back in the days, we used to run like on a weekly basis the jobs that do generate HTML for our public profile. So Google and other types of search engines can easily index our pages and bring some traffic to us from search engines. But yeah, most of the engines are not that smart, but we still need this point of traffic for us. So one of the solutions, at first point, we thought this is unfortunate to run JavaScript on a server side, but looked like there is no other way. So we should try this road at least and see whether we'll get some benefit out of it. One of the worries we had at the time, how good we will have a performance out of it. We know that we can output HTML if we do run JavaScript on a server. But the main question was the performance at that point. And we started to look around, and we get back to, like Brian mentioned, no solution at the beginning, the C++ solution. So our key tier is, our key proxy tier is based on ATS. It's Apache traffic server, C++ based, I would say C++ based. And we start looking around what we can use to run all of our JavaScript on a server. And it should be in C++, because we don't even have a choice at this time. And the best pick is like Google V8 engine. Actually, this is the same engine we are running in Chrome these days. So we can just reuse it, and it will behave the same as it behaves in Google Chrome. So it's a good pick. It's Google continue developing on that. We have but the only problem with that is, I would say, on most of the Google products we use, the documentation is not that great, I would say at all. So there are no samples, there are no good documentation. This is a blame to Google in comparison with Microsoft, at least, where I spent 3.5 years before. So server-side rendering, what going on here? So as Brian mentioned, we're using Fizzy as a data aggregator mechanism. So we introduced a server-side rendering component on the same tier. And we adjusted a little bit the language, how the application talk to our proxy tier. So now, what does the application return? We didn't change that much, but we introduced one additional step. So now application can pick whether it wants its data to run on the server side or on a client side. So we introduced a small key, like fs render control in this example. So at this point, application, let's say, advertise it in our system as I wanna run myself on a server side. So, and the output would be like this. So we run it on the server side, we get HTML back, and we just have a pure HTML and send it to the browser. Sounds like a great approach from this point of view. We linked all of this together. It used to work. Okay, let's move on and try to scale it. Like at LinkedIn, we have these days, like I would say, tens of millions of the requests to this server-side engine. So, but at the beginning, not everything was so clear. So we say, yeah, that could be a new fancy architecture. One more, we had a client-side architecture, now we have a server-side architecture. Support all the browsers, all of them. I would say with IE7 and sometimes with IE8, we had some very weird problems when our profile page took like 30 seconds to load because of the JavaScript and big JSON data on a client. So now we can handle every search engine because we output just HTML, and all of the engines just must use this data to index our pages. And we, at the end I will mention, we even were surprised with that running some JavaScript on a server, we can execute JavaScript on a server sometimes faster than the most modern browser in the world. But not all of this was very, very clear. So what could possibly go wrong in this case? When you use a shared engine on a server, it means you're sharing the same engine between millions and 10 millions of the requests. With a previous solution, we don't do that because we just delegate this job to the client, and browser could just handle this isolation. So now we can hit all the issues with vulnerabilities, and we want to make sure we don't affect different users. So the main reason for this is you can simply hit a situation with a context pollution when one request can hurt the other request, or one request can, I don't know, you can access the data from one request and another. So this is like a very, very blocking point for us, because on a server side we render user-specific data, and you can't just leak it. You can't just leak it. So this is a very, very simple example how you can do that. For example, you run some JavaScript in your engine, and someone just add this code to the JavaScript function. There could be a possible situation then the next JavaScript that we will run for absolutely different independent request will try to access this function, and it expects something very different. Not like sum, but real math-pow function. And what Google V8 engine gives you, it gives you a concept of context when you can isolate the JavaScript into a different context. So we run a separate context for every request. This gives you an opportunity to isolate all the data between the requests. So this sounds also like a win-win thing, since also V8 supports a nested content model. So we don't reload all of our environment for JavaScript in this case. We still use Dash.js to run all of these templates. So what it gives you, you can create a nested content, you can create a master content where you compile all the Dash.js things, all the heavy loaded JavaScript that you need for your environment, and a nested context where you just have only unique data per request. One other thing is also that is very important for browsers, but not so important for client, but so some of the engineers, and actually in our infrastructure, we don't control the developers of the page. We don't control the engineers who develop this JavaScript code. And there could be a situation that we have a JavaScript code that takes a while to execute. So this is a very basic example on how you can create a function that will take a long to execute it all. Why this is a huge problem for a server. If you run a shared engine on a server, it means you actually can execute one job at a time in one thread. So the highest level of parallelism you can reach is the number of threads you can run in parallel in your system. This is linked to the number of CPUs you have. So, and imagine we have some server machine that gives you an ability to run 32 threads in parallel. And imagine we have a problem with this JavaScript. In this case, you kind of blocked. So you can block all your threads until they end running this JavaScript. And what does it mean you block all of your customers at all? Because you can't execute any other JavaScript, you can't take any other job from the queue to continue, because this one takes infinite amount of time. I don't know. So, but speaking of that, there is nothing we can't solve. We started with a situation, we introduced a limit for our engineers that we are not going to take any JavaScript to our engine that runs more than 1 second. Yes. And one other thing, we always kill a JavaScript if it takes, kill a job if it takes more than a second to run. So, and we did some testing on that, and we figured out that there are like only 0.1% of the requests it takes longer than 1 second. So, and we asked our engineering team to fix all of this. So moving on, and in talking about scalability, the biggest thing we hit while we were scaling was a garbage collection thing. like, no matter what JavaScript engine you use, this is, let's say, your responsibility to do all the garbage collection stuff. And you should make sure most of the times that it doesn't slow down your request, and let's say it's at least behave normally. So this is an example, one of the examples. We have a lot of metrics at LinkedIn, like checking how our engine behaves. This is the example. So we introduced this feature. We start ramping it up until some point. And usually at LinkedIn, we have this paradigm of traffic shifts. We have multiple data centers. And from time to time, in order to test one data center, we take all traffic from all the data centers and send them just to one. And at this point, we start seeing that it starts blowing up. So average queue time, that's the job spent in the queue until it gets picked up by our engine, just went through the roof. So we start looking at what is going on. And this is the clear thing how the garbage collection metrics looks like in this case. So we clearly identified this is a problem of a garbage collection, and it's a good thing is there are a lot of mechanisms to tune garbage collection on V8. So you can do it like code-wise, you can do it like config-wise with V8, but as I mentioned before, the documentation is just, I would say, there's no documentation on that except of some people on the Google groups asking random questions. So I'll talk later about some parameters that we use to tune it, but after this, we jumped back into this picture. And now when we do a traffic shift, like rarely we have like queue time greater than 5 milliseconds for our jobs. And I would say for profile, the longest, just to mention, the average time to render the JavaScript on the server for us is like around 30, 35 milliseconds. So those are the things that we can use to do a GC tuning. So there is a way to adjust all generation to be several order of magnitude less than new generation. That helps a lot. And new generation is critical because it's a short-life jobs and contexts. Also, we figured out that we need more threads in order to run more VM engines because we can simply run only one engine on a thread. But on the other hand, with more threads, you will need more memory because one VM and one V8 engine takes probably like half a gig of your memory. So, and ideas for future. So what is the current state? We ramped many pages to use this server-side rendering when one of the big customers within the company is a profile. We ramped it like based on today to 70% of our requests go through this. And what we identified that in most of the developing countries, we hit a great win on JavaScript execution. We see a huge improvement even on modern browsers in like China, India, Africa, and all of these countries, where there are still a lot of people not using modern browsers. And from this, we are also going to think of like a generic JS engine we can use for our request, because since we linked our solution to a Dust.js, where we render templates. But going forward, let's say maybe every one of you knows about like Java 8 new features, where it supports JavaScript natively, where you can run JavaScript natively. But as we mentioned before, we don't have only Java code at LinkedIn. We have, if you have any like framework on your mind, probably we have some people working with this framework at LinkedIn. So we don't expect this feature will go out shortly. But yeah, some of the applications will probably move to like Nashorn in Java 8. So yeah, this is what we have so far, if you have any questions.
What do you guys use to actually measure the performance, like the rendering performance in the browser?
RAM.
User metrics, so it's similar to Boomerang, which was an open source project. And basically, it's all run on the client side, allows us to capture metrics like how much time is the browser spending with DNS resolution, connecting, right? Post it all back from the client side, able to actually do real comparisons and say server-side time versus, yeah.
I would say we don't use cache at all on Fizzy server. This is not because, and if you think of the other way, we don't need to use a cache on the Fizzy server. We cache a static content, we cache templates, let's say, in the middle, in our media servers. So fetching them is let's say, is like milliseconds or something. But we don't cache anything else because most of the times we can't cache because the data is different all the time. So we can't just cache JSON because it's always different. So and friendly speaking, there's nothing we can cache there at all.
How many concurrent contexts on one VM?
Just one. So we run, on our servers, we run 24 VMs on one server. So we can execute 24 jobs in parallel. And as I mentioned, on average, it takes like 30 milliseconds per job. It depends on how big of a JavaScript and JSON we are rendering. So it's not like that flexible that where you can run like, it's not like async or something like that. You can't just feed 1,000 jobs to the VM and get async calls back once something is done. Once you run one job, you're blocked on this thread.
Would it be a win to go with Docker and get cheaper context and more?
I think one of the main reasons why we have chosen V8 because it's the most modern one. It's used by Google. It's used by most of the people using, well, by all of the people using Chrome. We expected, let's say, less bugs, but we expect also more documentation on that because we literally spend a lot of time tuning on all of these things. And one other reason is like Google is right across the street from LinkedIn. So we can simply ping them on an email or sometimes meet during the lunch.
Can I expand on the Docker question? So you would use Docker for isolation, right? So you use isolation through Docker, but that's the thing is you need the JavaScript. Well, no. When we say VM, we're not talking virtual machine in the sense that we have a hypervisor. We're talking virtual machine in the sense that we have a JavaScript execution environment. These are all running on the same physical hardware with no hypervisor in the middle. The VM concept itself is V8. So to accomplish the isolation, we're using the V8 contexts, which is going to be way lighter than separating through Docker and running separate isolated environments.
Where?
Does that play into effect with your rendering at all?
Crazy URLs.
I've seen LinkedIn URLs that are 100 characters long.
Okay.
_star, 1 _star, or whatever. Does that play in at all with the backside rendering at all? URLs that then pump your browsing history. They are not being associated with one-side rendering.
And moving forward, I think where you will no longer see those huge URLs in future.
It's sort of a mechanism of the regex keeping state in the URL. Yeah. Okay. But yeah, those URLs are ridiculous.
Understand, it might be a waste of time, I need to investigate myself, but
That's fine.
I don't understand the issue in trying to get past using Dust.js and moving to some generic JavaScript solution besides Dust.js. I don't understand the problem.
The problem there is we need a language to, at first we need a templating language, how to do all of this stuff. One other thing is we don't want to do it from scratch by ourselves. So we looked what is on the market, what is like open sourceable, where we still have a lot of commits, where the community is still active. We did a lot of tests in terms of performance, in terms of our needs. And yes, we picked Dust.js at this point. And actually, we built our own Dust.js version. So we actually contributed into the open source community. As Brian mentioned, we have our own version of Dust.js. And we have actually a team at LinkedIn that supports Dust.js and do development on Dust.js now. It were like, I would say 3 or 4 people doing it full time. So it's actually now not that Dust.js we have chosen at the very beginning, but it is very different. We almost rebuild it.
Yeah, but you said you wanted to Python. Also, I don't understand why.
It has to do with the same reason we're using Dust.js now. So we went with Dust.js because client-side templating was the future. The problem is client-side templating strictly is not the future. Now you're seeing things like Angular, you're seeing things like Backbone, you're seeing things like Ember. You're seeing these very rich client-side frameworks, MVC client-side frameworks. So the question is, it's not simple templates anymore. So now you're having to deal with the concept of MVC on the client. So now think about how would you possibly have an Angular application now that's at least partially rendered on the server. It's a much different task. So what that's attempting to address is that eventually you're going to have to start coming up with the idea of a virtual DOM, a DOM that lives on the server that you can somewhat pre-populate and ship down to Bootstrap, let's say, in Angular or Embry or some kind of backbone JS application.
Yeah.
So that's the problem. That's not possible today with
Sure. So you could potentially dynamically alter the processing load between the server and the client.
Yes. You can simply delegate some JavaScript to the client and some JavaScript to the server.
But what struck me about it is I thought you were saying to make it generic. That sounds like a very targeted.
Well, generic means we still have a lot of requests where some of the teams just run some random JavaScript on the server. Let's say they have a JavaScript, they can run it on a client or on a server. And they figure out that on a client, for some reason, it takes so long or it doesn't behave well or something like that. And at this point, we have a lot of requests when we can just run any JavaScript. So, and one of the solutions, as I mentioned, is a Java 8, Nashorn, where you can run any JavaScript if you want natively. But as I also mentioned before,
Well, that's not going to work client side.
it's not going to work, but
It's going to be server side.
but you can still, let's say, distribute. If you have a lot of JavaScripts to run, I would say it is not ideal to delegate all of this job to the browser. Because while running the JavaScript, browser spends a lot of CPU cycles on just running the JavaScript. And when you run something like random JavaScript on a server, in this case, we can introduce some caching and reusable contexts. Since if you run same JavaScript over and over just with different data, you can simply, at this point, we can think of sharing the contexts between the requests.
So do you guys wind up seeing compromises on network time because you're now sending back larger payloads? You're processing a lighter weight JSON payload server You're sending back what if I or much more. So how is it much slower?
Yeah, where is the compromise here? If you think of client-side rendering, what should be delivered to the page? It should be a JSON. There should be templates as well. So templates are, let's say, are not small sometimes. If you do a server-side, we fetch these templates within our data centers. So some of our pages, let's say profile, they can easily have 50 different templates on the page. So the home page, we are talking about 150 templates on the page. So if you speak of client-side, you have to deliver all of these 150 templates to the client somehow or the wire.
And you have the benefit of caching.
In this case, you have a benefit on caching. That's true. But from our perspective, it's still a win for us to do it server-side. Since we track all of these metrics like time to first byte, page load time, render time, how fast we see something on a page, and things like that. And yes, we thought about it, but still for some, it depends on the page, let's say. But for like heavy loaded pages like profile, this is just a win-win thing.
For the browser to deal with. So network transfer time might go up, but user perceived load time actually comes down. Content to the client quicker, but what it has to do once it gets to that content takes a lot longer than the HTML only case. So that's really where your trade-off comes in.
It varies because like if I'm sitting on a fast Wi-Fi, certainly, but if I'm on a slow mobile connection, then you can.
Yeah, but also on a cell phone, you probably wouldn't like some huge JavaScript to run on your cell phone, right? So you can deliver purely HTML for this case as well. Actually, one of the big customers for us within the company as well are like mobile, when they want for most of the requests to get just HTML without running JavaScript at all as well, to display something.
But a big part of it depends on balancing how much dynamic interaction you want on the client. That's got to be driven by JavaScript.
Yeah, but yeah, no. We are not saying that we move all JavaScript to the server. All the client interactions, all the client-specific things are still there. So we can't just move them out. And usually everywhere, like I mentioned, we can't run everything on client side. We can't run everything on server side. So usually what you should look for is to some sort of a mix that is going to work for you, like we found in our case. So running the template rendering and operating with huge JSONs was a nightmare for clients, let's say, 2 years ago. Some of the JSONs, if you do a view, I would say if you do a view source on profile page, let's say, some of the JSONs are like terribly huge. Any other questions? Nope. Okay, thank you very much for attending this talk.